Raise your hand if you or a classmate build an erupting volcano for a school science fair. Now imagine that type of project times 1,000. That's a fraction of what students at WPI are doing in explosion protection engineering, a new academic area at WPI and the first of its kind in the nation. Hi, I'm Colleen Wambach from the WPI Marketing Communications Division. On this episode of the WPI podcast, we'll dive into how professors are blowing up the curriculum to support this important research and why this type of engineering is needed now more than ever. Just ahead, we'll hear what ignited one student's passion to pursue this field and a faculty member's take on why this industry sector is bursting with opportunity. Our first guest is Hannah Murray, who holds a bachelor's and master's degree from WPI and is now pursuing her PhD in explosion protection engineering. Hi, Hannah. Thanks for being here today. Let's start with the basics. What is explosion protection engineering?
Hi, Colleen. Thank you so much for having me. I'm really excited to talk about explosion protection engineering. It is often unheard of when I tell people that I do it. Broadly, explosion protection engineering is understanding how an incident could occur, where it could occur, the factors that go into the cause, and then how we can mathematically, using our systems of equations, fundamental science, break down that phenomenon and then engineer and develop different mitigation strategies. So there's all kinds of different strategies that we can use to either suppress, prevent totally, or redirect the explosion. So there's a lot of different avenues. It's a niche field, but it can be very in-depth as well.
What sparked your interest in this field?
That's a good pun. So my personal interest, I have a background in civil engineering from WPI in my bachelor's. I graduated in 2021 with that. And during that time, I was at a WPI career fair and landed an internship with the general contractor. So I was on a construction site during that internship. In Scottsdale, Arizona, I was at a water treatment facility, and it was actually the summer of 2020, so it was COVID. Very interesting construction site dynamics, but the whole point of this story is that one day a contractor came to site, and it was the fire protection engineering contractor. And what he was doing that day, we were doing an acceptance test of an inerting gas system in this room. It was the electrical room of the water treatment facility, was essentially sealed like a bubble. And so if a fire were to start in the electrical room, they would inject argon or nitrogen to drop the oxygen concentration below the limit that would sustain combustion. And that blew my mind. I had never heard of such a thing. I didn't know we could do that, control and manipulate the gases in the atmosphere and seal a room that way. And so luckily, by happen chance, I am a student at WPI. I was a student at the time, and we had the master's in fire protection engineering, so I continued on my track.
Never did I think you were going to say at a water treatment plant is when you got into explosion protection engineering. The two, at first glance, do not go together, so you never know where inspiration is going to strike.
Right. And that was fire protection engineering. Explosion protection engineering was a different story too. When I graduated with my master's at WPI in fire protection, I got a job as a fire protection consultant and was thrown into what's called a dust hazard analysis with additive manufacturing, 3D printing airplane parts with metal dust. I was thrown into this because the two people who were educated in the topic had resigned. And so the VP comes to me and he goes, "Hey, we really need someone to pick up this project. Do you have an interest?" And I always say yes.
Can you explain the difference between fire protection engineering and what you're learning or adapting to explosion protection engineering?
The main difference I've found with explosion protection engineering is the tendency for the reaction to happen on orders of magnitude faster than fire. And it all happens quite at once. And the main thing with explosion protection engineering is understanding how detrimental the pressure wave can be from that explosion. So that's what's causing structural failures, damage to people's lives and property surrounding the explosion. Fire and explosions may be intertwined. One can happen first and then one subsequent, or vice versa. So it's a very dynamic phenomenon, but with explosion protection, it is not like a fire. We can see it burning for sometimes hours, unfortunately. But explosions, I mean, it's almost like it happens and it's just too late. You don't even know what happened. And how do you backtrack and do the investigation behind that? It's just so quick and it's so detrimental to property and people.
Can you give an example of where explosion protection engineering is used in the real world? Maybe industry, public safety, even space exploration?
Yes, all of the above. A lot of industrial hazards that we are finding for explosions applications. Aerospace engineering has a huge overlap with explosion protection engineering, just in the inherent design of the combustion engines that power these rockets. Even cars. In cars, the combustion engines of a droplet of gasoline is inherently explosions. It's a tiny combustion in the engine that makes our car run. I found that fascinating. As far as where explosion engineering applications may be, there's a number of different systems. So it can range from the consulting and report writing versus product development and design. So talking about stopping an explosion, we actually can do that. There are valves we can install in process systems. There's all kinds of other different mechanisms. There's explosion vents that can be designed, explosion suppression systems, whether by chemical suppression or an inerting agent. There's a lot of different consulting and design services that can be offered. So it is really everywhere. It's in space, it's on ships, it's every high school in America with a woodworking classroom and a dust collector is at risk of an explosion just in that wood dust collector.
Explosion protection engineering may not be a common term or a program that a lot of people have heard about. It has been in existence for a long time. Why the need now to have a specialized program?
It's so remarkable that Dr. Rangwala has rolled out the first ever explosion protection engineering master's program at WPI because the field is so niche. And the work that we do as explosion protection experts really requires the right training to apply the correct math, physics, science, and understanding there's so many different variables that go into an explosion. Ambient temperature, ambient pressure, the types of gases, how many gases we have, what structure are we in, what kind of facility are we working with, the type of fuel, aluminum dust and titanium dust. Any legacy metal, when it reacts with water, will produce hydrogen, but only in the dust form. So there's a lot of intricacies that will affect the severity of an explosion. So I think that in the codes, when they call for this work should be done by a subject matter expert, it really needs to be done by a subject matter expert because our goal is to save people's lives. And if that's not fulfilled by someone who truly knows what they're doing, it could result in tragic loss.
Yeah, and unfortunately, we have seen that with the Merrimack Valley explosions from several years ago here in Massachusetts. In fact, in New York, there was an explosion on a sewage transport boat. That was a chemical reaction. Who would have thought that on a sewage boat? So it really can be seen anywhere and everywhere. Are we also seeing it more with emerging technologies, clean tech, energy storage? I mentioned the industrial accidents, but is this another example of prevention, mitigation, trying to catch up with innovation?
Absolutely. I do agree that as our energy grid is innovated, which is exciting, and it's great that we have all these fantastic engineers and scientists working to make our world hopefully a better place. We, as safety experts in explosion protection engineering, will be reactive to the technology that comes out and rolls out. There was a cargo ship off the coast of Alaska carrying 3,000 vehicles, 800 of them were EVs. And somehow a fire started on board, spread throughout the EVs, and luckily the Coast Guard was able to rescue all 22 crew. So there were no casualties or injuries, but it's unfortunate because even though the crew followed all of the emergency procedures that they were supposed to, salt water was corroding the batteries that they were trying to use to extinguish the fire. So it was just forcing more batteries into thermal runaway.
WPI prides itself on being interdisciplinary. This seems to be the definition of that it takes so many different aspects of science, technology, engineering to get to the root of the problem and prevent tragedy.
I love that this field of explosion and fire protection engineering is so interdisciplinary. That's really what drew me to it as well. You can come from a civil engineering background, mechanical, chemical, physics, math, and you can still excel and contribute. As we move forward into the age of AI, it is important that us engineers use code language. I'm so happy to have come back to the PhD at this time. In my master's program in 2022, when I graduated, we didn't use ChatGPT. Unless you were a computer science major, I had not heard of any coding language. And now that's all I use is Python and developing models with my codes and streamlining my documents in my PowerPoints. So I think that having that discipline of a computer science technical background is going to be really important moving forward as we get more use of AI, hopefully in a beneficial way. And of course, there's the physics, math, chemistry, mechanical engineering, even people with trades, people with like hands-on site experience are so valuable in this field because coming from school and then going out into a site and either visually inspecting an explosion protection system or a fire suppression system is totally different than seeing it on paper.
Are you looking for innovations to mitigate explosions, prevent explosions, be that stopgap? And or are you looking for new codes and regulations so these reactions don't occur?
They are kind of hand in hand. Something else I'm learning is that many wonderful scientists have already invented a lot of things, so we know a lot. And now, coming into a PhD, I'm learning that a lot of it is building off of what other people have done and refining. And there are a lot of things that we may have started in the 70s that people have disproven and given data on why, but no one has really come up with an amicable solution to that. So it's a lot of refining. How good is good enough? Through the program, our goal is in the explosion protection and developing research. I will just speak for myself and my experience so far. Something really valuable for me would be to develop something, whether that is a physical product, codes that can be used by future students coming through the program to learn about modeling, or contributing to policy and the codes and standards in fire and explosion protection engineering through refining other people's work and figuring out how we can benefit companies and industry that way. I think there's a lot of different, either tangible or not, ways to contribute. So as long as it's of quality and thorough, I'd be pretty happy.
If you could design your dream job in this field, what would it be?
I was waiting for this question. I would love to have my own independent business, but I would also love to work with really hardworking people with integrity and a passion for what they do. And what that would look like is site visits to clients with real industrial hazards. I do enjoy consulting. Research and development is also very purposeful and continuously innovating. I think there's value in policy and engineering's opinions in lawmaking as well, especially with our energy grid moving forward into the future. I think that there's a place for forensic investigation and special witnesses on the court stand. I think that as long as I keep learning every day, doing new things, meeting new clients and people, and building connections, to me, that would be my dream job.
How does it feel knowing the work you're doing could literally save lives?
I really take inspiration from my mom. She works in the medical field and they save lives. And so for me to kind of do the same thing, but in a math and science different way, it's so purposeful. I find a lot of value in knowing that even when I'm writing my codes or doing what seems like just literature review or research, it is of value. And all these little steps could go into saving someone's lives. In this industry, we hope something never happens, but if it does and our design has let someone go home to their family that night when they're at their job trying to make a living, that's what it's all about.
Extremely well put. And I'm so glad that whatever sparked your interest in this, ignited your passion, grows into something beautiful and bright, and I'm sure it will. Thank you so much, Hannah, for your time. And honestly, I look forward to seeing what's next.
Thank you, Colleen.
Next up, Steve Kimotek, a chemical engineering professor of practice and the co-director of the new Explosion Protection Engineering program. We just heard from Hannah Marie about her experience. So Steve, can you tell us about your background and what led you to get involved in explosion protection engineering?
I don't think you can be a chemical engineer without being involved in explosion engineering. So I came to it by default. It started because there were a lot of incidents in the chemical industry. I was working in a number of different chemical industries over the years, and we had some very, very serious incidents. As example, we had one case of a drum of furfural alcohol explode. Fortunately, there were no injuries. I had another case where I was no longer working in this place, but we had a case of a methyl trichlorosilane cylinder explode, and unfortunately, that person perished. So it came to it by necessity.
You touched on this, why it's so important in the industry, and we can dive into that a little bit more later, but why is this so important for students to study?
This actually, ABET, the Accreditation Bureau, has pushed this in chemical engineering because of the number of incidents within the chemical industry. There have been some very large process safety incidents where there were explosions, reactors exploding, on and on. But there are also, daily, there are small incidents. So the Accreditation Bureau and virtually every chemical engineering department and fire safety department has pushed this because it's required. Students have to be aware of the hazards that they're dealing with. And just like we train them in thermodynamics or train them in general engineering science, we must train them to be aware of the hazards and to take proper precautions and proper engineering controls.
Why did WPI decide to establish explosion protection engineering as part of its focus areas?
We established it, frankly, out of need. We have a long history at WPI of explosion protection or explosion engineering. We only have to go back to the early 1900s, and Dr. Robert Goddard was working on his liquid fuel rocket. And he was working in Salisbury Labs and blew out a wall when one of his rockets exploded, which got him moved to Clark University, which sent him back to WPI, which sent him to the then vacant magnetics lab at the corner of the campus, now the Skull Tomb, and a very well-protected environment. And he never did explode anything from out of there, but people did hear loud bangs coming out of the tomb. So we have a long history with explosions. By the way, Goddard was an innovator in explosion protection. If you look at the early designs of his first liquid fuel rocket, the rocket that went up in Auburn, it had on it one of the very first pressure relief valves ever on an industrial commercial activity. And he did that out of necessity. We set up the program out of necessity. It was a natural extension from the fire protection. NFPA has asked for it. All the agencies have asked for it. And we have responded.
Can you talk a little bit about why aerospace, beyond just the Goddard instance, and other departments, areas of study that this would pertain to or be a pathway for?
So the aerospace has two routes for its involvement. The first is the obvious combustion. We are using jet fuel, highly flammable explosive material on purpose, and you have a perfect mix and perfect potential for an explosion. And we certainly have had incidents where there has been an explosion. Probably less obvious, we have a lot of electronics now in any cars, but also any planes, any autonomous vehicles. Those all have batteries. We have all seen problems with electronic cars, batteries from cars, batteries all over the place, and we've had batteries in planes explode. So you ask what other majors? Electrical engineering. We have batteries. Any place where there is the potential for a rapid source of energy. Mechanical engineering has all sorts of potential, and we have mechanical engineers on the group. There are some computer engineering, again, for the electronics. Chemical engineering, it's all through us. You wouldn't expect something like biomedical engineering or biology, and yet look at a BL4 laboratory where you could have the potential of an explosion of a pathogen.
What are some examples of either codes or innovations that come from explosion protection engineering?
The field is still relatively new, I will say that. So the codes are still being developed. It's really only been a few years since the discipline has started to gel. So we are quite cutting edge on this. You asked innovation, and I'll go back to the example of Robert Goddard and his pressure relief valve. So one of the challenges in an explosion versus, say, a fire can start with a spark, and it can take a few seconds for, say, a fire to fully develop. In explosion, a detonation can take a nanosecond or a microsecond. So the timescales are so much quicker. What does that mean from a practical standpoint? I cannot react as a human. I cannot react in a microsecond. I can react maybe in a millisecond. And by the time that signals and I see something and I can react, now we're talking maybe a fraction of a second, but still fractions of a second, not microseconds. So I need something that can respond incredibly quickly. One of the earliest innovations, and I mentioned this with Goddard, one of the earliest innovations was to engineer something that fails and fails safely and fails quickly without interference or without input from me or, frankly, a computer. You can think of a Jiffy Pop popcorn. And what do? You start heating up the popcorn on the stove or on a heat source, and as the popcorn expands, pops and expands, which is fundamentally a little explosion on a very small scale, what happens? The aluminum foil starts to expand and ultimately bursts, allowing some steam to get out. And so what you can do in the example of a pressure relief valve, which is what Goddard did, is put in a system that will fail. It's a cheap system, it's easy, and you can set it so it fails in a safe manner. Goddard put his relief valve with a little shield away from the liquid fuel that he was burning, and a little deflector so that it kept that explosion, should it happen, away from the fuel, and the fuel system would not blow up. That is what we can do. A fail-safe system. And we can put in engineering what is called rupture discs or pressure relief valves, things that will fail and fail in a safe manner at a safe location away from people.
You indicated this is a very new academic discipline. In fact, WPI offers the first of its kind in the nation. There are some other programs scattered across the globe, but what is the differentiator for WPI's program?
One of the differentiators is the interdisciplinarity of the program. We are probably unique in having all the different disciplines that are affected, and we can bring resources from each. As example, the chemical process safety and the design of relief valves fall squarely in chemical engineering. Fire dynamics and explosion dynamics fall squarely in fire protection. The combustion systems and the battery systems fall squarely in aero. So you start to see we're drawing people from all sorts of disciplines, and we have the perfect match of all of those disciplines.
What kind of hands-on experiences or projects do students take part in?
In chemical engineering, we have had several projects associated with explosions and explosion modeling and explosion protection. One example is actually based on that furfural alcohol explosion that I mentioned earlier in the podcast. The initial incident started because a contaminant got into furfural alcohol, a contaminant that had previously been unknown in the literature for causing a runaway reaction that would cause an explosion. What our students did was characterize that explosion, and they characterized the heat release and the pressure release, and to further help develop the sizing, the appropriate sizing for a relief valve. Now, we're still developing the hands-on experimentation in fire protection. And one of my colleagues, Ali Rangwala, is looking particularly at dust explosions and coming up with some wonderful, wonderful reactors to do that. We have also worked with some colleagues at University of Lorraine in Nancy, France, and done some explosions on grain silos. They're looking at additives to reduce the potential for explosion of grains.
What kinds of careers do graduates of this program go into, could go into?
Oh my. So the answers are almost endless. First, any chemical engineer, fire protection engineer, aero engineer could use this material, could gain this material, and be useful in very traditional roles. I used to be at Dow Chemical, now DuPont. We had, at our site of about 1,000 people, we had probably 10 people who were devoted solely to chemical process safety. This is a growing field. Places like, first of all, NFPA, the people who are writing the standards, are hiring people, are bringing people on, bringing experts in the field. Insurance companies, so FM Global, people like that, are bringing people on because they're doing risk assessments and setting insurance standards for places that have the potential for explosions. There are any number of consulting firms who are working on fire suppression systems. We are working with all of them. The list is really quite endless.
You mentioned your time in industry and also being a professor of chemical engineering. It seems like this is marrying both worlds from the theory and practice that WPI is known for and applying it now to bring up students to address life-saving technologies. So how does that feel?
It is highly motivational. Our students no longer go into, by and large, traditional commodity chemical businesses. within chemical engineering. They're going to new and exciting fields and developing fields in specialty businesses, in businesses at a lot of startup companies, people who do not have this awareness. So to bring this and bring the knowledge base, bring the awareness so that our students can then apply this information and save lives, quite literally save lives, is highly motivating. It is one of the reasons why I wanted to end career back at a place as wonderful as WPI.
Thank you so much for your insight today. It's been a pleasure.
It has been a pleasure for myself also.
This has been an episode of the WPI podcast. To learn more about explosion protection engineering, visit our website. You can find it under Academic Area of Studies. You can hear more episodes of this podcast and more like this one at wpi.edu/listen. There, you can also find audio versions of stories about our students, faculty, and staff. Everything from events to research. You can also check out the latest WPI news on Spotify, Apple Podcasts, and YouTube Podcasts. You can also ask Alexa to open WPI. This podcast was produced at the Global Lab in the Innovation Studio. I had audio engineering help today from PhD candidate Varun Bhatt. Tune in next time for another edition of the WPI podcast. I'm Colleen Wambach.